Okay, so welcome to lesson 45, Solve Radical Equations, lesson 45 of Algebraic Concepts. This is going to seem out of place, but I am doing this now because we're in the middle of solving equations. Usually you don't get to radical equations until you get to polynomial work, but I am going to do it now just to show you that PEMDAS is working backwards. So we saw a little bit of this in literal formulas and literal equations, the last lesson, but I'm going to go a little further and explain why we do what we do. Okay. So solve radical equations, an equation with a radical. And if you don't remember what a radical is, please go back into numbers and operations and watch those lessons on exponent laws. There were like 4 or 5 lessons on exponent laws. They were somewhere in the 80s. I don't remember off the top of my head. Pause these and read through these. Okay, so let's look at our first example. This whole thing is under the square root. And so this should say solve for D, because D is our unknown. So basically, you do one step at a time. This is the square root because there's no number here, so we know that it's assumed to be 2. Because there's no number in the circle, we know that it's 2, and it's called the square root. So we got the square root of 15D. Now, the opposite of the square root is the square. So what we can do is square the whole equation. And so 3600 equals 15D. Squaring makes square roots go away, and square roots make squares go away. So when we divide by 15 on both sides, we get 240 equals D. And then you can always check this by putting 240 back in and multiplying 15 times 240 to see if what you come up with. And you should come up with, you would do 30 times 0.5 times 240, get a number, and then take the square root of it, and that will give you 60. So that is that for example 1. Okay, so let's have the square root of x plus 2 equals 5. So now, this plus 2 is not in the group with the square root. So we're going to get rid of it. And so you have the square root of x equals 3. So remember, we're working PEMDAS backwards. We got rid of the addition and subtraction, and now we have the square root, which is its own group by itself. Now we square the whole equation, both sides, because whatever you do to one side, you can do to the other. And so if you stick 9 back in, the square root of 9 is 3. 3 plus 2 is 5, so it works. All right, let's look at our next example. Our next example is the square root of x minus 2, the whole thing. So now, as we see, this whole thing is in the group. So let's just square the whole thing. And so you were left with x minus 2, and 8 squared is 64. If we add 2 and add 2, then x will be 66. So that is that. All right, for this one, let us take this as the square root of b plus 3. Okay, so 5 minus the square root of b plus 3 equals 1. So the first thing we have to do is get rid of the 5. So we're going to get rid of 5, subtract 5 from both sides. Negative b plus 3 equals negative 4. We're going to divide both sides by negative 1. Okay, from here, we got rid of the negative, so we have the square root of b plus 3 equal to 4. So now let's square the whole equation. And so we have b plus 3 equals 16. Subtract 3 from both sides, and b will equal 13. So 13 plus 3 is 16. The square root of 4, so 5 minus 4 is 1. So that works. Okay. Those were our examples. So you know the routine. Use these to try to solve a couple, and I will see you at the end of the video for the recap. Yep. What's up, babe?
Do you repeat run too?
Yep.
Mm-hmm. Do you want to go get this flipping stuff?
Sure.
Why don't you just go? I don't need it.
Yeah, let's just both go. That makes sense if we both go.
Cold outside.
Just put on your puffy jacket. It'll be all right. Okay, so let's look at what we have. We have 3 times the square root of x plus 8 equals 2. So again, you're going to subtract 8 from both sides. So that leaves you with 3 square root x equals negative 6. Then we're going to divide both sides by 3. So the square root of x equals negative 2. Okay, so let's stop right here. The square root cannot be a negative number. The root of x cannot be negative, so this has no solutions. And let me show you why. So traditionally, we would square this, and then you would get x equal to 4. But when you put it back in, 3 times the square root of 4 plus 8 equals 2. 3 times 2 plus 8, 6 plus 8 does not equal 2. So if you were to check this, this would not work. So when you are working with radical equations and you get down to your square root, the right side cannot be negative. So that was a tricky one. All right, and then we have 5 times the quantity x plus 2. So the first thing we had to do is get rid of the 5 because we work our PEMDAS backwards. X plus 2 equals 1. Square both sides. X plus 2 equals 1 minus 2 from both sides. X equals negative 1. So x can be a negative number, but the square root of whatever the left side is cannot equal a negative. So because this works, how do we know this works? Negative 1 plus 2 is positive 1. So the square root of positive 1 is 1. So 5 equals 5. Okay, again. Combine like terms, the sign in front of the term goes with the number. 8 plus the square root of a equals 1. Subtract 8 from both sides, and you get the square root of a equals negative 7. Again, we have one with no real solutions. No solutions. Because if we squared it and got 49 and then we took the positive square root, 5 plus 7 plus 3 would not equal to 1. And you cannot take the square root of a negative number for right now. And we'll learn what to do with that later, much later in the future. But for right now, these two, 1 and 3, have no real solutions. So if you got numbers and you tried to put them back in and check your work, you will see that you got a mistake. But if you did not check your work, you will assume that 1 and 3 had real answers, in which they do not, because the answers do not work. Okay, and so this is the whole square root of n15 over 6, which is a group. So how do we get rid of a group? Well, we multiply by the denominator, or the bottom, and we got n minus 15 equals negative 12. And again, the square root, whatever's on the left under the square root, cannot equal negative. So here's another one with no real solutions. And keep this one. I should have probably did this one later, but I stuck it in here in the solving equations ones. This will make sense in a future time. So let me say this parenthetically. I have done a series of videos about the number system, and we have real numbers. Which are rational and irrational. And this is back in my numbers and operations. I cannot remember. Under rational numbers, you have integers, you have whole numbers, whole, and you have counting or natural. These are groups of numbers or natural. There's another set of numbers above the real number system that's above this, and we're going to talk about that at a later point in time. So keep 1, 3, and 4 in the back of your mind because they will come up in the future, and we're going to work with those things. So thank you for being with me, and I will see you in the next video. Subscribe to the channel, all of that good stuff.